Welcome to the CAD Office training series for F.Connect for OpenBridge Modeler. My name is Joel Gutierrez and I am a structural engineer with WSP USA. In this video, we will be covering exercise 6.3 from the Bridge Design 3D Modeling and Plans course guide. This exercise demonstrates how to create a plan and elevation sheet using the Place Named Boundary tool. Let's get started. Now in this video, we're going to start with a little background information on the tools that it takes to go about creating the plan and elevation sheet. We'll first touch on the Place Named Boundary tool and discuss working with the plan and elevation named boundaries. Then we will touch on working with the profile model and using the section callout tool and how that will be used in this process. Next, we'll start going through exercise 6.3 step by step and create the plan view that will be included in our plan and elevation sheet. Then we will use the profile model to generate the terrain elevation view and also create a sheet model through that. Next, we'll create a bridge elevation view. And then finally, we'll combine all views into one cohesive plan and elevation sheet. Now, the first tool we're going to discuss is the Place Named Boundary tool. This is the tool that we use when we're looking to set up our plan view and the terrain elevation. Essentially, what this tool does is creates a thing called a named boundary, which is just a closed element with a name associated with it. And it uses this boundary to create a 2D display of our 3D model. Then it also will automate the drawing and sheet creation process by using specific toggles within the tool. There's several different methods for how we place the actual boundaries themselves. The two most important ones we use in the creation of the plan and elevation sheet are going to be the civil plan and civil profile. Civil plan is the first placement option available within the Place Named Boundary tool. There are many different toggles that are within the tool, which we'll demonstrate in the actual exercise, but two important things to note are that this placement option requires an alignment for it to be associated with, and then the user must also define the station limits for where to place the actual boundary along the alignment. The civil profile placement option is used when working in the profile model. Again, there are several different options and toggles that we'll have with this that we'll demonstrate in the actual exercise, but one of the important things really to note is that the limits can be either user-defined, similar to the plan view, or we can link the limits directly to the existing plan view limits. The next important component of this process is the profile model. So the way we access an actual profile model is by using the Open Profile Model tool. And what that does is just generates a view showing the profile that is associated with whichever alignment is selected. Once the user is within that view, you'll notice that there is the profile that's associated with the alignment shown and nothing else. So the next thing that you would do is use the tool called the Create 3D Cut tool, and that will essentially just create a longitudinal section along the selected alignment. This tool is extremely useful when we're looking to extract our existing ground line. So if we have our terrain model already referenced in and associated with the bridge, we can use this tool to extract that existing ground line, which you will see in this exercise. The other thing that you can use it for is to show 3D modeled components. So if you have the levels turned on for the bridge model, it will display those bridge components, as well as if you had some kind of roadway model that's being referenced in and displayed, it will also show any proposed underpass roadway model that you have in there. So that can be a very good way to show any kind of proposed ground line for any roadway passing underneath. Now the last component in the creation of our plan and elevation sheet is going to be the section callout tool and how that gets used to create our bridge elevation. So in the past, when we've been working in MicroStation and just using line work as opposed to a 3D model to generate our plans, elevation views have been drawn at the PGL. Now that we're working in OpenBridge Modeler and trying to use a model-centric plan workflow, it gets a little bit difficult to recreate this exact method. So what could be attempted is using the 3D cut tool in the profile model. However, that's not recommended because all that tool will do is show exactly what is present along the selected alignment. So if we do not have every component present in one longitudinal section along the bridge, it's not going to give you the proper view of your bridge. So for instance, along your alignment, if there is not deck, haunch, beam, pedestals, cap, and column all present, then you're not going to get the correct view. And this is also particularly difficult for chorded curved bridges like we have in our example here. So it has been found to be the most effective tool when trying to create a bridge elevation view is to use the section callout tool. This will allow us to capture a full bridge within a saved view, and it really will show a true elevation view. It is a little bit different in that we will see some kind of three-dimensional view, but this way we can fully capture all elements of the bridge itself. Then after that elevation view is created, it'll then be superimposed on top of our existing ground line that's been created from our profile model. So with all that background information now discussed, we can start going step by step through the exercise. So as we start with any of our exercises in this course guide, we need to make sure that we have the correct DGN open. To make sure that we have opened up our underscore 6.3 underscore begin DGN. And then from here, we're going to get started creating a new plan and elevation sheet file. So to do that, we're going to go up into the FDOT tab in the OpenBridge Modeler workflow, and then go over to the Actions group and click Create File. So from here, we're going to make sure that we're selecting the correct base file name. We're going to be looking for the plan and elevation base file name, so we'll go up to the File group, go into the Structure Sheet Files, and that's where we'll find it. Once we scroll down, you'll see the B number plan elev. So we want to click on that. Then we'll enter in our bridge number. We'll go with 01. We can leave our file sequence as 01. Output folder will be where this file is sent to. That's just going to be the structures folder within your work set folder. We'll make sure that the seed file is correctly showing our f.obm structure seed 3D DGN. Then lastly, we just need to set our county to be Pasco. Now we can go ahead and click Open File. And that will just create our new plan and elevation sheet file. So once that opens up, we can close this Create File window. Now we're just going to go ahead and set the annotation scale for this model. So to do that, we'll go up to the Reports and Drawings tab up here, and then just change the annotation scale up here to 1 inch equals 30 feet. Now lastly for this step, we just want to name our model plan. So let's go ahead and go up to Home. We'll open up the Models window, select the model, and then if you don't already have the properties docked off to the side, you can select the Properties button right here. That'll open up your properties. Now with the properties open, you can change the name and the description to both be plan. So we'll go ahead and do that. Plan and plan. And with that now updated, we can close the models window, go up to our references tool and open that window. And here we're going to reference in our main bridge model. So go up to attach reference, click that, navigate to the 6.3 underscore begin file. We go ahead and click on that one. Then the only thing that should need to be changed is setting the nesting depth to 1. Should be able to leave everything else as default. The model should be default. Detail scale should come in at 1 inch equals 30 feet. We want to make sure that our live nesting is on so that that nesting depth comes through. Then all other options can remain as their default options. With that set, we can click OK, and that will reference in our bridge model. So we can go ahead and close the references window, and then fit view to get our bridge model into view. Next, we're going to start placing our named boundaries for the plan view. So to make sure that those come in on the correct level, we want to set the active level to be clip boundary underscore DP. So we'll start by going to the drawing workflow, staying in the home tab here, and going into the attributes group. We can just change the level right here to clip drawing bound. It should be right here. So with that now selected, we'll open up our level display window. So in our level display window, we're going to select the reference to make sure we're turning off all the correct levels. And we want to make sure we're turning off everything that is not necessary for our plan and elevation sheet. So essentially the levels that we need are our 2D to core levels for the barriers, deck, and support lines. And then we'll leave on our 3D levels for the end bent cap, cheek wall, and pier cap and column. I'm just going to do that by turning off all the levels and then ticking back on the necessary ones. So I'll right click all off, and then I'm just going to turn on each of our individual bridge levels. So column, cap for the pier, end bent cheek wall, end bent cap, our decor barriers, our decor deck, and our decor support lines as well. The last thing we have to ensure that we have turned on is anything associated with the alignment. So let's turn back on all of the tick marks and our baseline survey level. So that should be everything that we need left on. And we can click Save Settings to ensure that those all stay as shown. Now with our level management completed, we can start our named boundary placement. So let's close the level display window, go back to our OpenBridge Modeler workflow, and then we're going to navigate to the Reports and Drawings tab. That's where you'll find the Place Named Boundary tool. So let's go ahead and click on that. Next, because we're going to be working with our plan view, we're going to select this Civil Plan option. So click on Civil Plan, which will be your first option here. Now to use the Civil Plan option, we need to select an actual alignment to place these boundaries along. So we'll go ahead and click our bridge alignment. So left click on the bridge alignment. And you should notice that the name now will automatically populate in our window here. You'll also notice this line, this red line that's coming along with my cursor here. That just is going to denote where our start point is going to be for the named boundary. So wherever we decide to click, that's where it's going to place the beginning point. So the next thing we'll need to do is select which drawing seed we want to use. So we'll go to the drawing seed drop down here, and you'll notice that there's two different sets of drawing seeds. We have a PE plan and a plan drawing seed. So the PE plan, PE stands for plan and elevation. So the intent is to create a named boundary that is long enough to take up the full width of the page, but then narrow enough to fit on the top portion of a sheet model. So the intent would be to have this view on top of an elevation view that comes in below on the sheet model. The ones that are named just plan, those are meant to take up the full sheet border. So when that gets referenced into the sheet model, it would take up the entire sheet. Additionally, you'll notice that there's several different sizes over here. So 11 through 15 for both the PE plan and plan versions. That's just going to dictate the length of the named boundary. So you'll see when I click on the 11, it automatically populates the length here to be 330 and then changes the offset to 75 on either side for the PE plan. If you go into PE plan 15 now, you'll notice that it automatically updates to a 450 foot length, but it keeps the same offsets. The offsets only change with whether you're choosing PE or not PE. So just to demonstrate, you'll see when I click on the similar size, but for just the plan, so instead of PE plan 15, we'll go plan 15. That keeps the same length, but it updates the offsets to either side so that it'll take up the full sheet model. For this exercise, we're going to go with the PE plan 14 inches. Next, we'll leave the name as plan 1. We'll update the name here to be just plan. And then hit tab to make sure it locks in that name. And then make sure that you have the create drawing toggled off. We'll only be creating the drawing after we've created our elevation view as well. So that will come into play later. That's everything we need at the moment, but I'll quickly touch on the last couple of different inputs you have here. So we're going to just select a station along the alignment here by clicking. But if you wanted to and you have specific locations you would like to start and end your named boundaries at, you can toggle these on and then hard input what stations you would like. I mentioned that the lengths and offsets will change automatically depending on which drawing seed you select. But if you prefer, you can go in and hard input whatever length and offset you'd like. The overlap dictates whether or not the named boundaries will overlap. If you create multiple boundaries, this will just dictate whether or not the ends line up with the beginning of the next boundary or if they're going to have some level of overlap. And then boundary chords will be how many line segments are along the sides of your named boundaries. So essentially, we'll notice that since this is a curved alignment, the named boundaries are not going to be a true curve. It's going to be line segments along the sides. So you can input however many chords you'd prefer. If you want it to look much more curved, you can enter in like 10 to 15. If the amount of chords doesn't matter so much, you can do fewer and leave it as is. So next we're going to go ahead and click at a location just before our approach slab to lock in our start location. So I'm going to left click right before the approach slab. And then you'll see it pops up with our full preview of our named boundary here. And then I'm going to zoom out and you'll also notice that you can place additional ones as I mentioned before. So if I drag this beyond the end of the named boundary, it'll populate another named boundary over here. So you could do that for as long as the alignment goes on. And as I mentioned, overlap would just be how much these boundaries overlap. Currently going to leave that at 0 for this example. So now you can see we've selected an appropriate drawing seed because it fits within the preview of the named boundary we have here. So we can go ahead and click at a point that's within the boundary, and that will create our named boundary. So left click once to set it, and then left click one more time to confirm. And now you'll see that the named boundary has turned into kind of a transparent color. That means it's been properly placed. So now we've completed the creation of our plan named boundary, and that will be used later on when we go to create our drawing models. So the next step in the plan and elevation sheet creation is to generate our terrain elevation view and create the drawing and sheet models. So this process is essentially just going to be us creating our existing ground line that's going to get used in the elevation view. To start, we're going to go ahead and open up view 2. I'll maximize, and then we're going to go to fit view to get our bridge within the view. Go to a top view, And then we're also going to change the display to wireframe. So all the way down at the bottom, we'll go ahead and click wireframe, and then click once in the window to change. So now it should match what we have in view 1. And here's where we're going to open up our profile model that we previously discussed. So to start, we're going to go back to the Civil tab at the top and go into the vertical group and click on Open Profile Model. Next, you'll need to select which alignment that we're going to be taking a look at. So we want to grab our existing ground line along the PGL here, so we'll go ahead and click that alignment. And then we'll left click one more time within the view to open that profile model. And you should see your full profile coming into view, as well as the terrain showing the existing ground line along your alignment. The ground line's already being shown because we have that set to active in the alignment file. And essentially what is being shown is just a reference to the alignment file. So you can see here, this whole profile and existing ground line is just a reference to the profile model in the alignment file. However, there may not always be a terrain file set to active in the alignment file. So another way to show your existing ground line is to create a 3D cut along your alignment. So I'll quickly just demonstrate how to do that if you don't have the terrain model active in your alignment file. So really quick, I'm going to go up to the level display and just turn off the terrain temporarily, just for the demonstration. So what you would end up doing from here is to click on the Create 3D Cut tool, and then you have the different placement methods are corner and full profile. We're just going to go with corners because we don't need the entire profile. We just need what's around the bridge. So I would left click to confirm that that's the selection that I want. And then I know that our bridge is around 2019 plus 0 and ends around 2024 plus 0. So we're going to set the begin point above the alignment around the start, and then below where we think the ground line might be beyond the end of the bridge. And then I'll click one more time. So you can see it's currently showing me what is shown in our design model. This is just a direct reference to our design model. And it's showing me all the 3D components that are along the alignment in that design model. So I can quickly just open up the references and see this is our 3D cut here. So you'll notice that the existing ground line is not shown here. That's because it's not actively turned on in our bridge model. There's two ways we can go about remedying this. We can either turn it on in our bridge model, or we can just simply attach the terrain file to this to the design model that's in this file. Either one would be fine. For this exercise, all I'm going to do is just turn on, I'm going to go into the level display and just turn it on manually in here. So now that I've turned that display on, I'm going to also just turn off everything else that's in the design model. And then I can click refresh 3D cut, and that should provide me with an updated view just showing the terrain. So that's all we would need to do if there is no terrain model active in our alignment. So now that I've demonstrated that, I'm just going to delete this 3D cut since we don't actually need it, and I'll turn back on the level that's already in the alignment file. So let me turn that back on, and we'll continue with our exercise as shown in the course guide. So our next step is going to be reopening the place name boundary tool so we can place our name boundary in our elevation view. You could always go back to the reports and drawings tab as we have before, but I want to demonstrate the fact that the tool can also be accessed through the drawing workflow. So if you go into the drawing workflow, go into the view tab, and then move over to the named boundaries group, you'll see the place name boundary tool there. So we'll just go ahead and click there. And then we're going to select the profile that we want to place our named boundary along. So we'll go ahead and click our profile. Then next you want to make sure that you're in the civil profile placement method. Before we were in our civil plan when we were doing our plan view, but now we're going to work in our civil profile. From there, we're going to update all of our inputs. So the drawing seed we need to select, you'll notice this, similar to the plan view, has a plain elevation drawing seed and a PE elevation drawing seed. Similar to the plan, the elevation is going to fit just the elevation on one sheet, and then the PE elev will place it underneath a plan view. So it'll fit the plan view and the elevation on the same sheet. So we're going to match the PE plan that we did before and just use the PE elev 14 to match size. That should update your detail scale, and then we're going to rename this to terrain_1. Next inputs that we need to change is our method. So we're going to change that from station limits, which would require you to input the location of the limits for this named boundary. Instead, we're going to use from plan group, which will use the same limits for this named boundary as we did in our plan named boundary. So it's a little more automated this way, that you don't have to go in and make additional placements for that. Plan group will just be which plan group you want to match the limits of. Since we only have placed one plan named boundary, it's going to be the only one that's available for selection. So we can leave that as is. And then we want to update the name to be terrain-1 and hit tab. Last couple of inputs that we need to change are going to be the profile shifts. We don't want our named boundary to shift along the profile at all. We want it just to go in a straight line. It's not going to matter much because it is just one named boundary as opposed to several different named boundaries. If you have several along the same alignment, then you would see it follow the profile. Since we're going to say do not shift, if you have multiple, it would just go in a straight line. So do not shift is what we'll set it to. And then the last thing we need to do is toggle on our create drawing option. This is just going to help us automate the drawing and sheet model creation process. So that is about everything that we need to take care of here. The last thing I'll just touch on is this vertical exaggeration. So if you wanted to show a scale that had an exaggerated vertical as opposed to the horizontal, so say you wanted to show it at four times the vertical as opposed to 1 horizontal foot, you would change whatever scale you want it to here. So if I say I want it to go 4:1, you would change it to 4. If you want it at any other scale, you would change it here. For this, we are going to leave it as 1:1, so we're going to just leave that as is. Now lastly, if you hover in the view here, you'll notice the preview of our named boundary. And then once you click, that'll confirm its location. So we'll left click here and confirm our location, and then your create drawing window should pop up. So there's a lot of information in this window, so I'll just try to quickly run through everything that we need to make updates to and give explanations to what things are. So the mode is going to be if we want to do both of the plan and elevation at the same time, or you could choose different ones. If you just want to do the plan view, you can do that. Just profile, you can do that. Or if you want to do them separately, you can do alternating. We're going to take care of them both at the same time. Next, we're going to update our view names. This is just going to be the name of the saved view that is created. So that'll show up as a title underneath the view that's created. So let's just go ahead and name this plan_1, and then the terrain we will name terrain_1. We've already selected our drawing seed, so we don't need to make changes to those. We'll leave those as is. We can update our model name here to match the view name. This is just going to be what the model gets called when it gets placed in the DGN here. And then lastly, in the drawing model portion, we are going to confirm that our annotation group are as shown here. So the annotation group we're going to leave as the OBM annotation groups. You'll notice there's a couple of different ones that you can select for both drawing models, the plan and the elevation drawing model, but we are going to leave the default plan annotation_OBM and the elevation grid_OBM. And then we're going to move on to the sheet model creation portion of the window. We're going to place these both on the same sheet, so you should only need to take care of the inputs on one side of this. Now we'll start updating the names here. We're going to name this plan and elevation_1. Name this plan and elevation_1. And lastly, we'll just confirm the detail scale is the 1 inch equals 30 feet that we had previously selected, and it is for both the plan view and the elevation view. The last thing to confirm is that we're not going to touch the annotation scale on the sheet model. If we were ever to change any annotation scales, it would be in the drawing model, and then you would have to update the detail scale accordingly. We'll never change the sheet model annotation scale from 1 to 1. It'll always remain 1 to 1. Now with all of that confirmed, we'll go ahead and click OK, and then that should create the drawing model for our plan view, the drawing model for our terrain view, and then the sheet model combining both of them. So we'll go ahead and click OK. And now you can see the sheet model here showing both views. I can also toggle over to our plan drawing model and our terrain drawing model. And both the plan and elevation drawing models have the appropriate annotation group applied to them as well. So you can see that on the sides there, as well as in the some of the cells that are placed in the drawing here. So like stuff like the north arrow and our traffic arrows get automatically placed in the plan view. Now our last step in this process is going to be creating our bridge elevation view, and then we're going to combine that elevation view with our terrain elevation. So before we start using the section callout tool, we'll need to create a new design model specifically for our elevation view. If you'll remember, when we were working with our plan design model, we had to turn off a lot of 3D elements to get our view to come through looking correct, as shown here, without all the extra line work. So we can't reference that specific design model, or else we would be missing a bunch of 3D line work in our bridge elevation view. Therefore, we'll need to create a new design model specifically for our elevation view. So we'll go ahead and open up the models window. You can see all the new models that were created. So we have our two drawing models shown here, the plan and terrain one, and then the joint sheet model here. Now we're going to create a new design model from a seed. So we'll go to the Create New Model button, change our type to Design from Seed. That's going to default to a 3D seed file, and then we're going to name the model Elevation. And we can just give it any kind of description. We'll just do elevation as well. Next, we're going to set our annotation scale, same as the plan design model, so that'll be 1 to 30. And we can go ahead and toggle off our cell properties here. Now with everything set, we can click OK, and that will create our new elevation design model. So I'll close the models window, and then we can reference in our bridge model. So we'll go up to our references, click attach reference, and we're going to click on our begin file, click open. If you had multiple models in the file, you would have to make sure you're selecting the right one. Fortunately, we only have the one, so we'll leave that as the default. Our detail scale should come in okay as shown. The only thing we should need to change is the nested attachments to no nesting. Next, we'll click OK, and that will place our bridge model in there. And then we're also going to attach the plan design model, just so we can get the location of our named boundary. So we'll go ahead and click attach reference again. We're going to navigate to our file that we're currently in, which is our B01 plan LF01. So with our main file selected, we'll click open. Now we're definitely going to want to make sure that we select the correct model because we have several models, as you saw in this file. So make sure that we're clicking on our plan design model. So it should be plan, descriptions plan. Everything can remain as default, and we'll leave no nesting as our nested attachments option. So we can go ahead and click OK on that, and that'll attach the plan design model. Since there's nothing else live in there besides the named boundary, that should be all that pops up in our reference. So we'll go ahead and close the references window, and then we'll fit to view. And you should see our named boundary from the plan model and the bridge model from our bridge design file. So next, staying in our drawing workflow, we're going to navigate to the section callout tool. So we'll go to the Annotate tab, go over to Detailing, and click on Section Callout. Now we want to make sure that we're selecting the right drawing seed. For our elevation view, we typically don't want to see any hidden lines or anything like that, so we're going to select a solid seed file, and then we're going to go with one that has no sheet number. So we'll click on 01 f.solid no sheet number. We want to leave the create drawing toggled on because that's going to create our drawing model. Then all we're going to do is go to the two corners of the name boundary that are on the bottom side of our view here, and then we're going to snap to each corner. So we'll click on the left corner here, move over to the right corner, snap there by left clicking, and then we're going to drag this all the way beyond the limits of the named boundary. And then you can left click one last time to confirm, and you're going to get the create drawing window pop up here. So now we'll go through a couple of inputs. We're going to update this to be elevation_1. We do want to create a drawing model, so we're going to leave that toggled on. We'll update this to be 30:1 to match the rest of our drawing models. And then we are going to toggle off the create sheet model option. Since we already have our sheet model created, all we need to do is create our drawing model, and then we'll reference that into the existing sheet model. So with everything else left as default inputs, we can click OK. And that will open up our new bridge elevation drawing model. Now you may notice in our new drawing model, there's a bunch of excess line work down at the bottom here. That's just all of our 2D decor levels as well as our clip boundary level. So if we want that to be turned off, we'll need to go back into our design model, turn the levels off there, and then all those level changes will propagate through the drawing and sheet models. So let's go back to our elevation design model. Go up to the Home tab and click on our level display. Then we can go ahead and click on our two references here and turn off everything we don't want. So we can turn off our decor levels. And then we can click over to the other reference up top here, the plan reference, and turn off our clip drawing boundary. Then to get those to stick, we'll click Save Settings. And now when we go into our elevation drawing model, we shouldn't see any of that line work anymore. Now our next step will be to combine this view in with our sheet model. So we'll go ahead and open our plan and elevation sheet model. Then we're going to open the models window, click on our elevation drawing model, and then we're going to just drag that into the sheet model. So click and drag and then drop. You can leave the attachment method as recommended and click OK. And then you can place that below the sheet. So left click below the sheet, and you'll see that it came in on top of the sheet here. So all that's done is create a reference to our elevation. So we can move that using the move reference tool however we'd like. So I'll move that down just a little bit so we can see it. So you may notice when you place the elevation in here, a lot of those levels have returned. So all those 2D levels have turned back on. If you go back to any of the other models and then return to our sheet model, it will go away. It's just a bug that kind of propagates through when initially placing it. Now we just need to get our bridge elevation located in the right spot. So as you saw before, the bridge elevation is just a reference. So we'll open up our reference window. I'll move that slightly out of the way so we can see the screen better. And then we're gonna just align this vertically and horizontally. So first we'll do it horizontally. We're gonna grab a location that would align with our plan view and line it up in the x-axis here. So we can right click on our reference and then click move. We'll click on the edge of the approach slab here, and this is gonna align with this edge of the approach slab. So we'll hover over the approach slab end and then set the Y input to 0, then tab. The X can remain as shown, and then we're just going to click to confirm our location. So now you should see that lining up. I'll just demonstrate quickly that it is aligned. So our plan view should line up exactly with our elevation view. Next, we need to just move this elevation view on top of where our profile is. So once again, we'll right click on our reference, click move. We would know from our model that our coping at the right edge of the begin approach slab is at 118.08. So we would just move that up here and get it approximately around that location. You can tab over to the X coordinate in the AccuDraw and type in 0 and tab so that that is locked. And then you can place this around that 118 value, which would be aligning with this tick mark here. So now with that placed, you should see everything sort of lining up correctly. We have our existing ground line and then our foundation placed below there. And then our top of roadway should pretty much line up with our profile that's being referenced in. So now with everything in place, should be looking pretty good. The last thing that I do want to demonstrate is how to correct this issue here. You'll notice that we have our piles going down into the sheet border, and we're showing way more pile than is necessary to be shown in a plan and elevation view. So to fix this, we can go into our elevation design model and we can just update the saved view. So we'll return to our elevation design model. Then we will go ahead and click on our saved view, our section callout. And then we can switch to a front view by clicking or holding down Shift, right click, and F. So that will rotate our view to a front view here. With that done, we can just use the Move tool with our section callout selected, and we'll move that to wherever we want to clip our piles. So I'm going to place it just below our footing here. So now I'll manipulate the saved view a little bit. I'll pull our handle up to the callout, and keep in mind you can update this saved view as much as you'd like. If you wanted to increase what is shown, you could always make that bigger by dragging the top and the bottom ones down. If there's more that needs to be shown on the left or right side, you could grab those handles. It's very, very easy to manipulate those. So now with that saved view updated, we'll return to our sheet model and we should see those piles cut off a little bit higher now. So we'll go back to the plan and elevation sheet model, and you'll see that cutoff moved up a little bit there. Now the last thing that you would do is go into each of those drawing models, and then you can just annotate your drawings as needed. Additionally, if we needed to move these titles, we can use the move tool. So if you just click on the title, click move, and we want to move this upward some, we can just move that into position, and that's all set. So that can be done with any of these. And with that, we now have our plan and elevation sheet fully created and ready for annotation. That's going to conclude exercise 6.3. And our next exercise is 6.4, where we'll demonstrate how to use the Civil Labeler tool. Thank you for watching this section of the training series for FDOT Connect. Additional training videos and course guides are available on the CAD Office Training webpage, which may be found at fdot.gov/CAD.